Functions. Sketching graphs. Here we're going to look at sketching a few different graphs. We're going to start off with one that we should know how to do. It's sketching quadratics. A few things we know about quadratics. We should be able to tell whether they're a happy quadratic or a sad quadratic just by looking at the coefficient of x squared. What that means is whether it's positive or negative. We can work out the y-intercept just by looking at that constant on the end. And we can work out the x-intercepts by solving it, usually by factorisation. So for this example here, we got y equals x squared plus 6x plus 8. We factorised it to give us x plus 4, x plus 2. That tells us our solutions are minus 4 and minus 2, so we can draw them in. It crosses the y-axis. We should really label that on our sketch as well. That's all we really need to do on a sketch. We could, if we wanted to, label the minimum point. We know the minimum point is halfway between the minus 2 and the minus 4, minus 3, and you could work out the y value. Alternatively, you could have completed the square to solve that. Another example, sketch y equals 3 plus 2x minus x squared. This is a negative quadratic, this is a sad looking quadratic. We can factorise it. You could factorise it in the same way as we've done before, or you could rearrange it. 3 minus x, 1 plus x. So remember it's negative. We've got two solutions, x equals 3, x equals minus 1. And we know it's got a y-intercept of 3 because it's the constant in the equation. Or you could sub in x equals 0 into the original equation. Something to note, if a is positive, then it's happy shaped. If a is negative, then it's sad shaped. That's something you should always look at. We move on to cubics. Cubics have two basic shapes. One of them's the normal shape, up, down, up. The other one's the special shape. Positive cubics are normal shapes, up, down, up. Special positive cubics don't do the down bit, they go up, pause, up, like this. Negative cubics, the opposite way around. They start off with really negative x's being really high. So they go down, up, down. And the special ones, very similar, go down, pause, down. That special one comes up a little bit more often than you'd think because it is the graph of x cubed. It's also if you have any transformation on that. So we'll look at an example. We'll sketch y equals x plus 3, x plus 1, and x minus 5. We put it into this factorised form to make it very easy to see what the factors are, make it very easy to see what the solutions are where it crosses the x-axis. Crosses through at minus 3, minus 1, and positive 5. It's a happy because all the x's are positive. So it goes up, down, up. We know where it crosses the y-axis by subbing in x equals 0, or just doing all the constants times together. 3 times 1 times minus 5 gives us minus 15. We'll have a look at another example. We'll sketch y equals x minus 4 squared times x minus 1. This one, because you've got two solutions at the same point. We've got one solution at 1 and two solutions at 4. So it's going to cross the axis going down and up at 4. The only way it can do that is by just touching the axes. So if they ever have a bracket squared, it means it just touches the axes. We can work out the y value by subbing in 0. We get minus 16. Another example, sketch y equals x minus 2 cubed. So this goes up, pause, up. All the solutions are at 2. So it goes up at 2, down at 2, and up again at 2. So the only way it can do that is up, pause, up. We'll have a look at another curve. We'll have a look at a reciprocal curve. A reciprocal curve contains a term of 1 over x. So we'll have a look at this through an example. We'll have a look at this as 12 over x. You can work out a few points on this. You can work out when x equals 1, y is 12. When x equals 2, y is 6. When x equals 3, y is 4. 4 gives 3, 6 gives 2, and 12 gives 1. So it forms this nice shape here. For the negative ones, it's exactly the same, just negative. Now you run into a problem at 0 because you can't divide a number by 0. So it doesn't have an answer there, it's disconnected. We'll have a look at another example of one of them. We'll sketch y equals 6 over x plus 5. You could work this out value by value for x is 1, 2, 3, and it will turn into this shape up here. So it's the same, it's just been translated upwards. But to show this line that they both go towards but never touch, we draw in one of these dotted lines. This dotted line has got a special name. It's called an asymptote. So that asymptote goes through 5. There's also an asymptote along the y-axis, but because the axis is there, we don't need to draw the dotted line over the top of the y-axis. So that's an asymptote. One last curve that we'll have a look at is an exponential curve. Exponential curves are curves which have an a to the x term. For example, 2 to the x, 3 to the x. There's a special exponential called e, but we'll look at that another time. So these have an a to the x term. For example, y equals 3 to the x. Easy ones, when x equals 1 it's 3, when x equals 2 it's 9, when x equals 3 it's 27. A little bit trickier, when x equals 0, 3 to the 0 equals 1. 3 to the minus 1 is 1 over 3, so it's a third. 3 to the minus 2, 1 over 9, 1 over 27. And so it ends up looking like this. All exponential curves look the same. They all go through 1, unless you've done the transformation on them. Thank you.